anatomy of the plumbing of the building, as I have discussed to you last time, ang lahat na ito, mga equipment, mga storage tank, ay dinidisenyo natin. Sinasize natin ang capacity ng storage tank natin from the cistern up to the overhead tank. Sinasize natin kung magkano yung gallons na kapasidad niyan or in cubic meter na kapasidad niyan of the cistern and how many cubic meter ang kapasidad ng storage tank. So, there is always a ratio between the cistern and the storage tank. Itong transfer pump natin, normally, 2-3 ito. Although isang riser pipe lang. Itong 3 o 2 transfer pump, they are all in automatic operation. Pump 1, we start, and then after filling it, when we start again, pump 2 will start, and then when we fill again, pump 3 will start. So respectively, it is in automatic operation. It should be both the same in capacity or in horsepower. So the distribution downfeed below, if it is the high-rise building, it may, from any point here, we need to reduce the pressure. Because a pressure of more than 70 psi is not acceptable for a plumbing engineering design. What if you have a 80 psi? Maybe it bursts, or it may be destroy some bulbs. That's why we have to lower down to 70 psi. The pressure reducing bulb is also designed. How much is the capacity of pressure reducing bulb? This may be the distribution is by zone. Zone 1, Zone 2, Zone 3, Zone 4. It depends upon the height of the building, where high pressure is below the building. Okay. The same thing also in the sewer stack, that each drain system are discharging to the sewer stack. If it is not designed, maybe the sewer stack is not appropriate or being sized correctly depending upon the discharge of the horizontal drain. The sewer pipe or the sewer stack is responsible of collecting all waste down going to the house sewer or to the STP. So, they are all responsible to collect and discharge to the sewer stack. We will design correspondingly the sewer stack also. And the venting system that we will have, since it needs to have ventilations, because when there is no ventilations, bumabaho tayo. Ang space lahat na nako-cover doon na nawala yung trap seal natin, nagbabaho. So binabaho ngayon. So a foul odor coming out, which is not healthy for the habitation of the tenants. We have also the rain stack. The rain stack is also designed depending upon the intensity of the rain that is being collected at the rooftop. So it is discharged also to the house sewer, or discharged also to the drainage system, or the public drainage system. So this is our register. Maybe we will apply also the rain water collection system. So we can impound the water here and being used as maybe a gray water for the building. And some other piping system here, like a fire protection system. This is part of the design for plumbing engineering. Okay, we will focus on this controversy of having this horizontal drain, because we cannot design this sewer stack if we do not know the discharge of the horizontal drain. We do not know where to offset. We do not know where to break the velocity. So we have to know first how much is the discharges of each horizontal drain that we will have. Okay. This is the curve as the results of the experiment of Dr. Roy Hunter. The curve estimate curve for the design purposes. This is from Dr. Roy Hunter, and he has elaborated also to a certain point that a predominantly flush valve and the predominantly flush tanks. So the fixtures unit versus the demand GPM is what Dr. Hunter say our loading is for plumbing system, in the design of the plumbing system. We translate this graph into a table. From the curve, this is now the table that we will have. On the x-axis, we have the fixtures unit loading. And in the demand GPM is in the y-axis of the curve. So it's easy to read than to read the intersection of the curve. How much is the fixtures loading and how much is the GPM. So, in all of our design, the predominantly flush tanks and predominantly flush valves, there is an equivalence of a demand GPM. Take note that a demand GPM for flush tanks is a little lesser than the demand GPM of a flush valve. So if your system is more on flush tanks, you get the value from the flush tanks. And if your system is more on flush valves, you get the value from flush valves. So these are the values. The loading that we will have in terms of fixtures unit, and the values of the demand GPM flush tanks, and the values of the demand GPM flush valves. Without this, we cannot make and we cannot proceed into our design. So we need a loading. Like I said before, that even a structural engineer, there is always a loading. In electrical engineering design, there is always a loading. In mechanical engineering design, there is always a loading. So, in a plumbing system design, there is always a loading. So we proceed on that loading because this is the controversial one. Why there is a fixtures unit here? From what point of experiment does Dr. Hunters did? I have not divulged to you yet. But this is from the horizontal drain. It discharges, as I explained to you last time, the discharge of one water closet to the horizontal drain. As we say, 7.5 gallons per minute. But that was not the case. Because of so many batteries of water closets, Dr. Hunters applied the theory of probability. So he first applied 5 gallons per minute per water closet. It's not 7.5. So the loading that we will have in terms of fixtures unit is dependent on the probability of how many appliance or fixtures discharging that horizontal drain. Okay, this is the basis of our loading. So the loading that we will have up to 5,000 fixtures unit. Up to 5,000. From 1 up to 5,000. So we can choose how many fixtures unit that we will have in terms of our loading in each floor that we will have.